So now in chapter 6, lesson 3a about decimal equations, we're going to take what we know about solving for a variable and our operations of adding, subtracting, multiplying, dividing. And we're going to take what we know about that, but instead of just using whole numbers or integers, we're going to plug in some decimals and we're going to plug in some fractions next time. This time it's just about decimal equations, and so your learning target is I know how to solve equations that have decimals. Okay, so there's really not much different from what we've done, except that we just need to just practice this a little bit. So let's get going on an example. Example 1, says solve 16 equals 0.25x, and then check our solution. Okay, so this is a multiplication problem, and I know that the division property of equality says that I can divide by the same side on, or the same thing on both sides of the equation and make everything the same, right? So I'm going to divide by 0.25 on both sides, because if I do that, if I divide by 0.25 on both sides, then 0.25 divided by 0.25 is just 1, or just 1 times x, so I can just write x on that one side. And then 16 divided by 0.25, you can do this any number of ways. The easiest way would be to call up a friend and say, hey, what's 16 divided by 0.25? And my friend says 64. Boom, x equals 64. And that's all you have to do right there. So you're using what you know about those properties, the division, the properties of equalities, division property of equality for this one, and you're going to solve for the variable still. Well, the only difference is that we're plugging in some decimals, and that makes it a little bit more tricky. Okay, let's do example 2. All right, example 2 says that to solve a minus 3.3 equals a negative 18.9, and then check our solution. So the first thing that we want to do is, because this is a subtraction problem, we want to use the addition property of equality that says that we can add something to both sides to make it stay equal. So we're going to add 3.3, because I know that if I add 3.3 to a negative 3.3, that is the additive identity of each other. They're going to they're going to just cancel each other out, and we're going to get 0. So I'm going to add 3.3 to both sides to keep everything balanced, and this will just be a on this side, and 18.9 plus a 3.3. Now, sorry, this is a negative 18.9 plus 3.3. This is where it gets a little tricky. Okay, remember, if we're adding positive and negative numbers together, so we're adding integers here, what we can actually do is, if they have different signs, we can subtract their values. Different signs meaning this is a negative number, this is a positive number. So we can subtract their values as if both were positive, and we get 9 minus 3 is 6. Put our decimal point where it goes. 8 minus 3 is 5, and we keep our 1 there. So we get a 15.6. Now the rule states that if the absolute value of the negative number is greater than the absolute value of the positive number, then your answer is going to be negative. So because 18.9 as a negative, the absolute value of that is 18.9, right, is way larger than the absolute value of 3.3, which is 3.3, then this answer is going to stay negative at negative 15.6. Negative 15.6. Therefore, A equals a negative 15.6. Now, one thing that you can do to just check your work and make sure that you're right is call up your friend again and say, okay, I want to know what is negative 18.9 plus 3.3, and you get negative 15.6. Hey, that's what I got too. And then get this, guess what you can do too, is you can plug negative 15.6 back into your problem here for A and make sure that that works out. So we have negative 15.6 minus 3.3, which is exactly what this would be right here, negative 15.6 minus 3.3, and we end up getting, enter button, negative 18.9. Negative 18.9. Everything checks out, everything works. That means that this answer is correct because we're ballers. Example 3 coming up. So before you start your practice problems, we're going to do example 3. And example 3 says that some dude named Frank wanted to buy ice cream for his little league team. Ice cream cones cost, or they are, $2.40 each. It wants us to write and solve an equation to find how many cones the coach can buy with $30. So we know here, we're going to set up this equation. We know that ice cream cones are $2.40. And we know that Frank buys some number of these. So I'm going to use C for cones. He buys some number of cones, and we know that it needs to be $30. This is how much he can buy with $30. So we set up our equation now, and now we can go about solving it. And remember, this is a multiplication problem, and the division property of equality says that I can divide by the same amount on each side. And everything will stay balanced. So I'm choosing to divide by 2.4 or 2.4D because we're talking about money here. Because $2.40 divided by itself is just going to cancel out, and it's going to be 1, or just C, which, remember, C is cones, right? Now we have to take 30 divided by 2.4 or 2.40. And this is where things are tricky. Dividing with decimals is just unreal, man. So let's get our calculator here, and let's go 30 divided by 2.4, and we are going to press enter and find 12.5. 12.5. And therefore, what that means then, C equals 12.5, and I can say the coach can buy... that would be the wrong form of buy, 12 and a half cones for his little leaguers. Oh, and that would be the wrong spelling of leaguers too. You get the point. Okay, so 12 and a half cones. That is how you solve with decimals. Not much different. Just takes a little bit more thinking because it's a little bit more difficult. All right. Have a great day.